Morning. Good morning. Good morning. Good morning. How many students are there? Okay. Now slowly, people are getting up. Okay. Good morning. So, anybody who is listening, how many of you have given the weekend test? Am I audible now? Sudeshna. Okay. Okay. So, one person has given the audible. Okay, so any doubt in the test paper? I think it was a simple basic all question. Most of the question we have. Hi, hello. Okay, good. So most of the question, I think everybody got one or two question. Maybe the problem. Okay, so later we can discuss. Suppose you have any doubt in any problem. Okay. Okay, so now I have to start what thermometry. Okay, so we will what I said earlier also. First, we will start with the thermal unit and dimension. We will cover in that another track because this year due to the re-need 10-20 days get delayed. Okay. Okay. Okay, so thermometry, is only one or two things is there in the thermal, like thermometer part. Okay, but we cannot ignore any topic now because from any topic they can ask the question and there is no any defined weightage is there according to the NTA. That's why all the topics we have to read properly. Okay, maybe we are ignoring the thermometer, but they will ask the question from the thermometer also. So any topic we don't have to leave. Okay. So thermometry, first we have to know about the temperature, different temperature scale. Okay, so everybody know the old thermometer. Nowadays we are using the digital thermometer. Earlier we were using the mercury thermometer in the glass tube. There was a mercury and it was showing the temperature according to the like different temperature. It was showing the reading. Okay. So older thermometer, we were using the two reference temperature. To make the thermometer, we were using the two reference temperature. One reference temperature was the ice point and the other reference temperature was the boiling point. Ice point and boiling point is what? Ice point we were taking as a lower fixed point. So one reference we were taking what? Ice or melting of ice or ice point we can say. Okay, so one reference temperature was the ice point, that is called the lower fixed point, LFP. We are using LFP. Okay, and the higher temperature was the boiling point that we call UFP, upper fixed point. Okay, so older thermometer we were using two reference temperature. One is the lower fixed point, one is the upper fixed point. Okay, suppose we want to make the mercury thermometer. Okay, so what we can do, suppose you have the one thin glass tube you are taking. Okay, in that thin glass tube, suppose I took mercury. Okay. Now in that glass tube, mercury is in the liquid state. So it was working on the principle of thermal expansion of the liquid. Okay, thermal expansion of the liquid. Now suppose what I said, we will take the two reference temperature. So this glass tube, that is a mercury is there. So we will put in the suppose boiling water. Okay, we put for the boiling water, wait for some time. Okay, when temperature of the boiling water and the temperature of mercury become equal, then what will happen? As the water is giving the heat, now as the mercury is taking heat, it will get expand. So when it is expanding, so what will happen? Its volume will increase. So it will start rising in this tube. Okay. So as temperature of the mercury is increasing, it is getting expand and level of the mercury is rising. So when we put in the boiling water, it will take some time because the thermal equilibrium is required. It will take some time. So the temperature of the mercury and the temperature of the boiling water, suppose it become equal. It become equal. So in suppose I am going to make the Celsius thermometer. So when we are putting the mercury in the boiling water, after some time the temperature of the boiling water and temperature of mercury become equal. So in the Celsius scale, we know that it is 100 degrees C. Okay. So what will happen when that mercury temperature will become 100? It will expand, it will rise. Suppose at 100 degrees C, it is rise up to this level. Mercury rise up to this level. So this we will mark as 100 degrees C. Okay. Because here temperature of the mercury become equal to the temperature of the boiling water. Okay. Now what we will do? Take this tube and now put in the suppose ice. Okay, and wait for some time so that the temperature of the ice become equal to the temperature of mercury. So when the temperature is decreasing, then what will happen? Mercury will start contracting, and when temperature of the mercury will become the temperature of the ice, then what will happen? Suppose mercury is pointing here, mercury goes up to this level. Okay, now this temperature we will mark as 0 degrees C. Okay, if I want to make the Celsius thermometer. Okay, now I mark 0 degrees C, I marked 100 degrees C. Okay, in between make the total number of 0 to 100 degrees C, make total number of 100 divisions. Okay, then it becomes the Celsius thermometer. Like that we were making the we can say we are making the thermometer where we were using the two reference temperature. Those two reference temperature is what? One is the ice point and other is the boiling point. And different scale we were using. Everybody got or not? So old thermometry we were using two reference temperature. One was the ice point and other was the ice point or freezing point, and other is the what? Boiling point or upper fixed point, UFP. Okay, everybody got or not? So we can say what? One reference temperature is what? LFP, that is what? Ice point. And other reference temperature is what? UFP, that is the boiling point. Okay. Up to this everybody got. Now mainly we have to deal with the 3 scale. Okay, somewhere rumor and all also given, but in the NCERT only 3 is given. So we will deal only with the 3 scale. Okay, so those 3 scale is what? Okay, so here suppose I am taking the first one is the Celsius scale. Okay, so in the Celsius scale, what is the lower fixed point? Celsius scale, what is the lower fixed point? That is a 0 degree C. So Celsius scale ice point is what? 0 degree C. Okay, then what is a UFP? UFP is what? 100 degrees C. Okay, boiling point in the Celsius scale is what? 100 degrees C. And total number of division what we are taking? 100. Okay. And here we can say what? 1 division is equal to what? 1 degree C. Okay. This everybody got. So what is the lower fixed point in the Celsius scale? 0 degree C. Upper fixed point is what? 100 degree C. And this temperature, this two reference temperature, total temperature difference, we are dividing into the 100 part or 100 divisions. Okay. So 1 division we can say it is a 1 degree C. Everybody got this? Most of you know also. Second is what? Kelvin. Okay, that is absolute scale. So Kelvin, what is the lower fixed point? In the Kelvin, what is the lower fixed point? In Kelvin, what is the lower fixed point? 273.15 Kelvin. Okay, and what is the upper fixed point? 373.15 Kelvin. Okay, and what is the number of division? 100, and we can say one division is equal to 1 Kelvin. Everybody got? In numerical problem, like we are using what? Like suppose Celsius, you want to convert in Kelvin. We are using the 273 because 0.15 value is small. But actual is what? If we want to convert the Celsius into Kelvin, or we can say like 0 degree C is equal to in Kelvin, 0 degree C, what we can write? 273.15. But in numerical, we are ignoring the 0.15. Like 27 degree C, we are directly taking as a 300 Kelvin. But actual relation is what? 0 degree C is equal to 273.15 Kelvin. Everybody got? Okay. Next one is what? Fahrenheit. Okay, what is the lower fixed point of the Fahrenheit scale? It is a 32 degree F. Okay, what is the upper fixed point? 212 degree F. And what is the total number of division? That is a 180. And one division is equal to 1 degree F. Okay, so lower fixed point of the Fahrenheit scale is the 32 degree F, and the upper fixed point is what? 212 degree F, and the total number of division is what? 180. So these three we have to know. Okay, now who will say in which scale one division is the smallest? In which scale one division is the smallest? In which scale one division is the smallest? In Fahrenheit scale. Why? Because the same temperature difference in the Celsius and Kelvin, it is divided into the 100 division, but same temperature difference in the Fahrenheit is divided into the 180 part. 180 division, it means each division will be smaller. Each division will be smaller. Everybody got? Completed? So we can say Fahrenheit, later you will learn the more precise instrument. So we can say the Fahrenheit is more precise because its one division is the smaller than the Celsius and Kelvin. Okay. Okay then. Up to this, okay. This values everybody know. Okay. Okay. Now in these thermometer where we are using the two reference temperature, okay, we are defining one quantity that I have written TSI. TSI means thermometer scale identity. Thermometer scale identity. So for those thermometer in which we are using two reference temperature, we are defining one quantity that is called the TSI. TSI is what? Thermometer scale identity. Okay, that we are writing as TSI is what? So what is a TSI? TSI is what? I have defined X minus LFP upon UFP minus LFP. Okay, LFP meaning everybody know lower fixed point. UFP means also everybody know. Basically UFP minus LFP, that we can say the total number of division in the given scale. UFP minus LFP we can write as a total number of division also. Okay, everybody got? What is the X here? X is the X is the reading of thermometer in given scale. So whatever the temperature you are measuring, that is a reading. X mean what? X we will take what? Suppose I am measuring my body temperature, then body temperature is same. But when I'm using the different thermometer, I'm using the Celsius thermometer, I'm using Fahrenheit thermometer, their reading will be different. But I'm measuring the my body temperature. Okay, like with the if I'm using the Celsius thermometer, it will be approximately 37. The reading will be 37, my body temperature. If I'm using the Fahrenheit thermometer, then the same my body temperature, what will be the reading? 98.4 approx. Okay, so what is the meaning of X here? X is the reading of a thermometer, reading of the thermometer for the given temperature. Okay, reading of the thermometer for the in a given temperature. Okay, whatever the temperature we are saying, for that it is a reading. Okay, everybody got or not? So we are defining the one quantity where we are using the two reference temperature. We are defining one quantity. What is that quantity? Thermometer scale identity. What is the thermometer scale identity? X minus LFP upon total number of division, or we can say UFP minus LFP. Okay, how we are using this this TSI? Okay, so TSI how we are using? When we are measuring the same temperature. Suppose we are measuring the same temperature. So temperature is same, but we know that different scale reading will be different. Okay, so for the given temperature, TSI of all the scale is constant. Again I am repeating, for the given temperature, TSI of all the scale are constant. TSI of all the scale are constant. So we can say what? For given temperature, TSI of all scales is constant. Okay, everybody got? By using this we can get the relation between the different scale. So what I said, for the given temperature we are measuring the one body temperature by the different scale. Okay, so then for the given temperature all the scale TSI will be equal. Okay, and remember that whether I'm using these three scale, Celsius, Fahrenheit, Kelvin, or it is a faulty thermometer, or it is a hypothetical thermometer, whatever they are saying, but when we are using the two reference temperature, then we can say what? For the given temperature, that TSI will be constant. Everybody got or not? Again, I'm repeating what I said. Where we are using the two reference temperature, okay, whether the known thermometer, or it is any unknown or hypothetical thermometer, or it is a faulty thermometer, for the given temperature TSI of all the thermometer we can say it will be constant. Constant means what I can say? Now suppose I am measuring any body temperature. Okay, I am measuring any body temperature. In Celsius scale its reading is C, in Fahrenheit scale its reading is F, and in Kelvin scale its reading is K. Same body temperature I am measuring, in different scale reading are different. Okay, then what is the meaning of this? I can say what? Celsius, then TSI of the Celsius, what I will write? C minus LFP of Celsius 0 upon 100 minus 0. Okay, this is the TSI of Celsius scale for any body temperature, for a given temperature. Suppose any temperature, any body temperature I am measuring, in Celsius scale I am getting the reading is C. Okay, now constant means it will be equal to the, suppose Kelvin scale is showing the reading K, then K minus 273.15 upon 373.15 minus 273.15, or total number of division directly we can take 100. Okay, is equal to, suppose Fahrenheit scale reading is the F, then F minus 32 by 212 minus 32. Okay, so what I said, for the given temperature, if we are measuring the one temperature, different scale will have different reading, different scale will have the different readings. Same temperature they are measuring, but reading will be different. How I can get the relation between them? By equating their TSI. So for the given temperature, Celsius scale TSI, Kelvin scale TSI, and Fahrenheit scale TSI. Okay, so further we can solve. Then C by 100, that is equal to K minus 273.15 by 100 is equal to F minus 32 by 180. Okay. So this relation directly you can remember. By this, we can get the relation between Celsius Kelvin, Kelvin Fahrenheit, Celsius and Fahrenheit. Okay. So by equating their TSI. Everybody got? Completed. So this relation we are using to get the relation between the different scale. Okay. What is the SCF of the denominator? What is the HCF of denominator? What is the SCF of denominator? SCF of denominator. What is the SCF of denominator? Basic mathematics we have learned 1 week. What is the SCF of denominator? So you can see na 10, 10, 10 and 2 means 20. We can say 20 is the HCF, means highest common factor in the all denominator, that is the 20. So if I am cancelling all that denominator with 20, then what I will get? C by 5 is equal to K minus 273.15 by 5 is equal to F minus 32 by 9. Everybody got? So means if I am cancelling all the denominator with 20, because 20 is the SCF of the denominator, then we can get this relation. So either you can use the above one or you can use this. Okay. So if you are forgetting 559, so better that we have to take the total number of division in denominator. Understood or not? Okay. Okay. So by using this, if I am saying what is the relation between Celsius and Kelvin? Okay, so Celsius and Kelvin, suppose I want to find the relation. So suppose 5 and 5 get cancelled out. K, what I can say? C plus 273.15. Okay, so this is the relation between the Kelvin and Celsius scale. Okay. Similarly, if I'm asking the relation between the F and C, then what is the relation? You will get F is equal to 9C by 5 plus 32. Okay, F is equal to 9C by 5 plus 32. Directly you can remember these two relation. Otherwise, suppose you are forgetting, getting confused, so you have to remember the TSI we can equate. Okay, by equating the TSI, if I need C in the terms of F, that also we can write F minus 32 into 5 by 9. Okay, otherwise directly you can remember F is equal to 9C by 5 plus 32, and the Kelvin scale we can say that will be equal to the Celsius scale reading plus 273.15. Are everybody got? Up to this okay? So if I want to convert one scale into the other scale for the given temperature, then we can use the TSI. Okay. Now next thing. Okay. Now listen. Sometimes I need to convert the one scale to the other scale, that is okay. Okay. Sometimes we need to convert the temperature difference. Okay. In one scale to the other scale. Like suppose I am saying, when we are putting the Celsius thermometer in the one body and the body is heating, suppose we are heating the body, change in temperature in Celsius scale is 20 degrees C. Change in or rise in temperature in Celsius scale is 20 degrees C. Rise and fall is what? It is a change in temperature. Suppose I am saying a body temperature rise by 20 degrees C. A body temperature rise by 20 degrees C. It means whatever the initial temperature was there, it increased by 20. Okay. By and to, it is a very small word, but it can create the difference in the problem, and by taking the wrong meaning, you can lose the 5 marks. So by means delta, by means change. Increase to, rise to means final. Okay. Suppose I am saying body temperature rise to 20 degrees C. Rise to 20 degrees C. It means from initial, now it increased up to the 20 degrees. So final temperature is 20 degrees C. That is the meaning is rise to 20 degrees C. If I am saying rise by 20 degrees C, so rise by 20 degrees C means whatever initial plus extra 20 degree C we have to add. So right, by and to, everybody has to read this word carefully. By means change, and to means final. Understood or not? In the 2024, they so many students has done the mistake on due to this. But every year we are saying the by to, what is the difference? Okay. So if you are not reading the question properly, then you can lose. Again, I am repeating, by means change, up to means or to means final value. Okay. So what I said, if suppose Celsius thermometer I put in the any body and the body is heating. So Celsius thermometer is showing the temperature of 20 degrees C rise, it is showing 20 degrees C, it is showing the rise. Okay. So in Fahrenheit scale, what will be the rise? In Kelvin scale, what will be the rise? Okay. So if I need the delta relation, change in the temperature relation, what I can do? Now listen. This relation, suppose I have C by 5 is equal to Fk minus 273.15 by 5 is equal to F minus 32 by 9. This relation we will use to convert the one scale into the other scale. But I want to get the relation between change in temperature or rise or fall in temperature I want. Okay. Then how we can get? So change means what? Change means delta. Change means delta. Okay. Delta always we will take what? Final minus initial. Delta means final minus initial. Okay. So I want to get the delta. How I can get? So in the basic mathematics, Akhilesh sir said, like when we are taking the change is small, like delta y by delta x, when we are taking the delta x is very small, so that delta x we are writing as a dx. That is the meaning of the differentiation, maybe Akhilesh sir said. Okay, so delta, when we are taking the small change, then we are writing as a d. Okay, so when delta x is small, then delta y by delta x we are writing as a dy by dx. Okay, so I need the delta in this relation, I need the change in this relation. What I can do? I can do the differentiation. So differentiate this relation, okay, or apply the delta. So what is the differentiation of C? Who will say? What is the differentiation of C? Okay, first you will say, what is the differentiation of X? Everybody has attended the 1 week basic mathematics class. So what is the differentiation of X? What is the differentiation of X, Nalayak? 1 1 0 1 1. Okay, 1 1. Listen one thing. Most of you are saying the 1 1 1 1 1. Listen now. One thing in general, what happened when I ask the when we ask the differentiation. So directly we say that dy by dx. Okay, means by default you assume that I am asking with respect to x, or anybody is asking with respect to x. So by this, sometime what will happen? You will miss some differential part. So what we will do? We are never calculating dy by dx. In the physics, what we are doing? We are differentiating left hand side and right hand side separately. Okay. So if I am asking that differentiation of x, so first you will say dx. Differentiation of x is dx. If I am saying differentiation of the x with respect to x, then you will say dx by dx, that will be equal to 1. So build this habit, means if I am asking what is the differentiation of y, you will not say dy by dx, you will say dy. You will say dy. If I am saying with respect to x, then you will say dy by dx. If I am saying with respect to t, you will say dy by dt. Everybody getting or not? So differentiation of x, I will not say 1. Differentiation of x, I will say dx. If I am saying with respect to x, then you will say dx by dx. Understood or not? Okay, because otherwise everywhere in the chapter this differentiation is coming, then you will face the problem. One more thing. Suppose I am saying what is the differentiation of x square? What is the differentiation of x square? What is the differentiation of x square? That is okay. Now x square, what is the formula you mucked up? X square differentiation, we remember 2x. Okay. So d of x square, that is okay. So d of x square, then I will apply the formula of x square. What is x square formula? 2x. Then we will write what? D of x square is what? 2x dx. 2x dx. Okay. So with respect to which we are differentiating, we will do the differentiation of that also, like dx. I'm saying that d of x square. So first you apply the formula. What is the formula? X square differentiation is 2x. And then we will write that dx also. If I'm saying differentiation of x square with respect to x, then you will say 2x dx by dx. That will be what? Cancel out. So what is the differentiation we will get? 2x. Are you getting my point or not? So if I am saying differentiation of x square, so we marked up the formula x square differentiation is 2x. But that is a 2x with respect to the x. So what we will remember? 2x into dx. 2x into dx. Okay. If I am asking with respect to x, so dx by dx will get cancel out. Understood? Okay. Okay now. So here I'm asking the differentiation of C. I want to differentiate the C. Here C is the variable. C can be the reading of the Celsius scale can change. So C is the variable. So what is the differentiation of C? I can say DC. Okay. C by 5, DC by 5. Like 2x differentiation is what? If I'm asking with respect to x, you will say what? 2. If I'm asking differentiation, then you will say 2dx. 2dx. Okay. Same way here I can write C by 5. C by 5 differentiation is what? DC by 5. DC by 5. That DC I can write as the delta C by 5. Okay. Everybody got this C by 5 differentiation? What we got? DC by 5. Because constant into the x, we are writing as the constant into dx. Okay. So this is the DC by 5, or that delta or d I can write as a delta. So what I got? Delta C by 5. What is the differentiation of this? K minus 273.15 by 5. What is the differentiation of K minus 273.15 by 5? Now slowly people are understanding. Okay, very good. So K minus 273.15 by 5. What is the differentiation? dk by 5. Good. So that is a dk by 5 or delta k by 5, because the 273.15 is constant, and constant differentiation is what? 0. Then directly what I will get? Delta k by 5 or dk by 5. Everybody got why? 273.15 is a constant. Constant differentiation is what? 0 with respect to whatever you are, with respect to which you are differentiating. With respect to x, with respect to y, constant differentiation is what? 0. Okay. Because delta change in the constant is a constant, that's why we are calling as constant. So what is the change in the constant? 0. So not required with respect to which constant differentiation will always be 0. Okay. Third one, what you will get? F minus 32 by 9. If you are differentiating, then what you will get? Delta F by 9. Delta F by 9. So this relation we will use for the temperature change. What is the relation? Delta C by 5 is equal to delta K by 5 is equal to delta F by 9, or we can use delta C by 100 is equal to delta K by 100 is equal to delta F by 180. Everybody understood or not? So if I want to convert the one scale into the other scale, we will use the TSI. We will use TSI. And when we want to convert the one temperature change into the other temperature change, we will use this delta relation. Okay. So from this we can say what? Delta C is equal to delta K. Delta C is equal to delta K, and delta F, what I will get? Delta F is equal to 9 by 5 into delta C. Okay. Like suppose I am saying what I asked. I put the thermometer, Celsius thermometer in the any body, and the body I am heating. And I put the Celsius thermometer. Celsius thermometer is showing the rise in temperature of 20 degrees C. Celsius thermometer is showing rise in temperature of the body by 20 degrees C. Okay. What is the rise in temperature shown by the Kelvin scale? What is the rise in temperature shown by the Kelvin scale? Again, I am repeating. I put the Celsius thermometer in any body, and the body temperature I am increasing. So that Celsius thermometer is showing the rise of 20 degrees C. What is the rise in temperature shown by the Kelvin scale? 20 degrees C, because by this relation, reading I'm not asking. For reading, I have to go to the TSI. I have to give the initial temperature and all. But directly what I can say, delta theta is same for both, so delta C and delta K will be same, but it will be different in the Fahrenheit scale, because for Fahrenheit scale we will use this relation. Everybody got? Okay. So for given temperature, for the same temperature, different scale will have different reading. For given temperature, different scale will have the different reading. To get the relation between their reading, we can use the TSI. We can equate the TSI. To get the temperature difference relation, we can differentiate it, and by differentiation, we are getting this relation. Everybody got? Okay. Now some question we will do. So one question that is very common, maybe most of you know the answer also. Find temperature in Fahrenheit scale. So the reading of Fahrenheit scale is double of Celsius scale. Okay, three question I gave first. Find the temperature at which Celsius and Fahrenheit scale shows the same reading or gives the same reading. Okay, you have to find the temperature. Find the temperature at which Celsius and Fahrenheit scale shows the same reading. Everybody got? Find the temperature at which Celsius and Fahrenheit scale shows same reading. So maybe everybody, maybe some of you know the direct answer also, minus 40 degrees C. But I am saying they are showing the same reading. We know that for same body temperature, same temperature, their readings will be different. This scale reading will be different. But is there any temperature for which both scale will show the same reading? That is the question. Everybody getting or not? So what I said, when we are measuring the same body temperature, same temperature, so different scale is showing that different reading. Okay, that we are getting by using TSI. But I'm asking here, is any temperature exist at which Celsius and Fahrenheit scale both will show the same reading? Okay, so it means what I can do in that? Suppose Celsius scale shows the reading X. Okay. If it is showing the reading X, then what I'm saying, Fahrenheit also has to show the same. It means I can say the F is equal to also what? X. Okay. Now I need the C and F. I will equate the TSI of the Celsius and Fahrenheit. Okay. Then I can say what? X by 5 is equal to, this I am writing for Celsius. For Fahrenheit, what I will write? X minus, or directly first I am writing the relation, C by 5 is equal to F minus 32 by 9. Now C and F both are, I need the same reading. So C is equal to what? X. So X by 5 is equal to X minus 32 by 9. Now cross multiplying, so 9X is equal to 5X minus 160. Then what you will get? 4X is equal to minus 160. Then X, what you got? X is equal to minus 40 degree F, you can say, or minus 40 degree C, you can say. So this is the one temperature at which Celsius and Fahrenheit scale will show the same reading. Different, same temperature, they are showing the different reading. But this is the only temperature at which Celsius and Fahrenheit scale will show the same reading. Everybody got or not? Understood? Okay. So this value we learned, the minus 40 degree C or minus 40 degree F, the reading will be same at this temperature. So one time I was going to Delhi in the Air India flight, and in that aeroplane, means every seat they were one screen was there. That screen was showing the height, okay, height and the temperature, okay. So I remember that last year it happened. So at the 36,000 feet, they were showing the height of that plane is the 36,000 feet, and then they were showing the temperature is minus 40 degree F, minus 40 degree F. Then after seeing that reading, immediately this question came in my mind. Means here minus 40 degree F it is showing. So suppose there is a Celsius scale, so the Celsius scale will also show the minus 40. So this is the temperature at which Celsius and Fahrenheit scale will show the same reading. Everybody got? Okay. Understood? Second question, what I'm asking? Second, I'm saying find the temperature at which Celsius and Kelvin scale will show the same reading. Celsius and Kelvin scale will show the same reading. So what is the answer of the second? Who will say? Find temperature at which Celsius and Kelvin scale will show the same reading. What is the answer? Temperature at which Celsius and Kelvin scale will show the same reading. What is the answer? No, it will not show the same. 0. Means 0, what? 0 Celsius or Kelvin. Means 0 is the temperature at which 0 Celsius and 0 Kelvin. Hiranmai, Harshita. 0 you are writing. So 0 means what? Means Celsius is showing 0 degree C, Kelvin is showing 0 Kelvin. I'm saying the temperature at which both will show the same reading. You are saying 0. Okay, so 0 means Celsius will show 0 degree C, Kelvin will show 0 Kelvin. No any temperature exists at which both will show the same reading. No any temperature. Why? If you want to convert the Celsius into Kelvin, what is the relation we have? K is equal to C plus 273.15. This is the relation or conversion factor of the conversion between the Celsius and Kelvin. Okay. To get the temperature in Kelvin, what we are doing? In Celsius, we are adding 273.15. Okay. Again, I am repeating. To get the temperature in Kelvin scale, we are adding the 273.15. Okay. If you add any number, suppose I am saying any number, I have X. In that, I am adding the 273.15. That number will be equal to X. Again, I am repeating. Suppose I have any number X. Okay. Means Celsius scale reading is suppose I am taking X. If I am adding 273.15 in that X, so what I will have? X plus 273.15. It can be X. After adding 273.15, it will be X. Again, X, suppose I am saying X is the reading of the Celsius thermometer, or X, I have any number X. In that I add the number 273. It will be remain X. No, after adding it will increase na bhai. Okay. Otherwise, mathematically, if you want to see, you can say, okay, both scale are showing the same reading. It means X is equal to X plus 273.15. Now, X cancel out what you got. 0 is equal to 273.15. 273.15 is the 273.15. 273.15 is not a zero. Nah. So this is possible. No, then it is not possible. So this is not possible. Everybody got or not? So there is no temperature, there is no any temperature at which both scale will show the same reading. Okay. So there is no temperature at which okay, this everybody got. Now third question what I'm asking. In third problem I'm saying find temperature in Fahrenheit scale. So the reading of the Fahrenheit scale is double of Celsius scale. Means we have to find the temperature when Fahrenheit scale, whatever Celsius is showing, Fahrenheit will show double of that. First question I discussed, both are showing equal. Then we got the -40. But what I'm saying, find the temperature at which Fahrenheit scale will show the reading double of the Celsius. So in which scale I'm asking? Find the temperature in Fahrenheit scale. So I'm asking in Fahrenheit scale. Okay. So remember that always it is better what we are asking, we will assume it. Okay. Here somebody can take, suppose Celsius is X. Celsius is X, then Fahrenheit will be 2X. Celsius is X, then Fahrenheit will be 2X. Or suppose what I'm asking here, suppose Fahrenheit scale reading is X. Then I'm saying find the temperature at which Fahrenheit scale reading is the double of the Celsius. Okay. So Fahrenheit scale is the X, so Celsius will be what? X by 2. This we can write or not? What I said, find the temperature in Fahrenheit scale at which reading of the Fahrenheit scale is the double of the Celsius. So if the Fahrenheit is X, so Celsius will be X by 2. Is it correct or not? Okay. Somebody can assume like this also. Suppose Celsius they are taking X, then Fahrenheit they can write as a, suppose Celsius I am taking as a Y, then Fahrenheit I can take as a 2Y. This also correct or not? If suppose in this problem Celsius I took Y, then Fahrenheit scale I can took the 2Y or not? Okay. I'm saying the mathematics step, okay, answer whatever you are getting, that is okay. But what is the silly mistakes you can do? This is correct or not? This I can take. Either I can take like F is equal to X, then C I can take the X by 2. And if I am taking the C is equal to Y, then Fahrenheit will be 2Y, because Fahrenheit is the double. So either I can take the first one or I will take the second one. Who will say what you will take? What we will prefer? First one or second one? Which one you will prefer? First one or second one? Second one. First one. Second one. Second one. That's why I'm discussing this, because it is not for this problem only, because it is for whole physics. Okay. If you are preferring the second, suppose you are writing the second question, what I'm saying, you have to find the temperature in Fahrenheit scale. So it means in the Fahrenheit you have to say the answer. Okay. If you are taking the second one, C is equal to Y, F is equal to 2Y, then what you will do, you will find the value of Y. And in the exam, we are in the hurry. So after finding the value of Y, you will forget to do the double. You will forget to do the double because I'm asking in Fahrenheit scale. So in Fahrenheit, what you have assumed 2Y. So you will find the value of Y. After finding the value of Y, now you will forget what you have assumed above. So directly you will see the value of Y in the option and you will get the answer 160. Okay, so there is a problem. But if you assume assume first one, F is equal to X and the C is equal to X by 2. So when you will calculate the X, so directly you got the temperature for the Fahrenheit scale. Okay, so if you assume the first one, so you will directly get the temperature in Fahrenheit scale. So always remember this point, whatever we are asking, always assume that. Okay, understood? So I will not prefer the second one, I will go to the first one, because I am asking in Fahrenheit scale, so directly I assume the Fahrenheit scale is equal to X. Then I can say Celsius will be X by 2. After finding the X value, no need to think anything, directly we will check the option. Okay. Now equate the TSI. X minus 32 by 9 is equal to, here C is what? X by 2, and the division is what? Here we will take the denominator is what? 5. Okay, then what we will get? 5 to the 10, so 10x minus 160, 320, that is equal to what? 9x. Then x, what well we got? 320 degree F. What is the temperature? When Fahrenheit will show 320 degree F, then the Celsius will show 160 degree C. Celsius will show 160 degree C. Everybody got the answer? Completed? Okay. Now next problem. If thermometer A has LFP and UFP is minus 20 degree A and 140 degree A. If reading of this thermometer is 60 degree A, then find reading of Celsius thermometer. So any hypothetical thermometer I'm taking A, okay. In that, what I'm saying, LFP is the minus 20 degree A, and what is the UFP? UFP I'm saying 140 degree A. If this thermometer measures any temperature and the reading is what? 60 degree A, then in Celsius scale, what will be the reading? That is a problem. Everybody got? So what I said, TSI relation, wherever we are using the two reference temperature, whether it is a hypothetical thermometer, it is a faulty thermometer, we can use the TSI relation, okay. Now what is the answer? So here I'm asking the answer in (50 degree C). 50 degree C. Any other? Most of the students are getting the answer 50. So here I am using the two reference temperature in the A also. So for the given temperature, I will equate the TSI of A, and I need the answer in Celsius, so I will use the TSI of Celsius. Okay. So for A, what is our reading given? 60. Okay. Minus LFP of A. What is LFP of A? Minus 20. Are everybody getting? Upon UFP minus LFP. What is the UFP? 140. Minus what is LFP? Minus 20. This everybody got or not? This is the TSI of A for the temperature 60. Everybody got or not? I have given the LFP is what? Minus 20. UFP what I gave? 140. And what is the temperature in the thermometer A? 60. So temperature in the given scale minus LFP of A upon UFP minus LFP. This everybody got or not? So this is a TSI of scale A. I want to convert in Celsius, so I will write what? C minus 0 by 5 or 100. What you will take? 5 or 100. That is another mistake what you can do. 5 or 100. 100. We will take the 100 because we are taking the 5 when we are cancelling the 20. We are cancelling the highest common factor in the Celsius, Kelvin and Fahrenheit. But here I am equating with a different scale. I cannot take here 5. Basically, what is the total number of division in Celsius? 100. So don't take the 5. Okay. Now this what I got, minus of minus means plus. So this is the 80 by 140 plus 20. That is a 160. 160. This is equal to what? C by 100. So now 0 and 0 get cancel out. Then here then 8, otherwise 16 5s are directly you can say 16 5s are 80. Okay, now C value what you got? C is equal to 50. So when the scale A is showing 60 degree C, then the Celsius scale will show the 50 degree C. Everybody got or not? Okay, completed. Next problem. Suppose I am saying accurate Celsius thermometer shows 60 degree C and Fahrenheit thermometer shows 141 degree F. 142 you can take. Okay, 143 degree F. Fahrenheit thermometer is showing the 140 degree F. Then find error in the reading of Fahrenheit thermometer. Tell fast. What I said, we have the accurate Celsius thermometer, and Celsius thermometer is showing the reading is what? 60 degrees C, and for that temperature Fahrenheit is showing what? 140 degree F. Then I am asking Celsius. I said it is an accurate thermometer. Maybe it is a faulty or not. Fahrenheit scale is faulty. So I am asking, what is the error in the Fahrenheit thermometer? Calculate and tell fast. What is the error in the Fahrenheit thermometer? Maybe it can be accurate also. When accurate Celsius thermometer, it is showing 60 degrees C, then the Fahrenheit thermometer is showing 140 degree F. Then I'm asking what is the error in the reading of the Fahrenheit thermometer. So how we can do? I gave Celsius temperature is what? 60. Celsius temperature is 60. So for Celsius 60, what should be the reading of the Fahrenheit scale? That I can get by using TSI. Okay, by using TSI. If suppose I am getting whatever the reading I am getting, I will compare with 143 and then I can get the error. Everybody got or not? So first find 60 degrees C, convert into the Fahrenheit. How? 60 by 5 is equal to F minus 32 by 9. Okay. Now this will be what? 12 5s are 60. Then F minus 32, that is equal to 12 9s are 108. So then Fahrenheit what you got? 140 degree F. So for 60 degree C, we can say what? 60 degree C is equal to 140 degree F. 60 degree C is equal to 140 degree F. But that Fahrenheit is showing how much? 143. So what is the error? Delta F error I can say. Error delta F is equal to what? 3 degree Fahrenheit. Everybody got or not? Completed? Okay. So similar question is given in our module also. So here 3 different thermometer I have shown. Thermometer X, thermometer Y and thermometer Z. Okay. Thermometer X, LFP what I gave minus 30 degree X, and UFP what I gave 60 degree X. Okay. Thermometer Y, I gave the LFP is what 30 degree Y, and UFP what I gave 120 degree Y. And the thermometer Z, LFP is the 0 degree Z, and the UFP is what 90 degree Z. This everybody got the data. What data I gave everybody got? Okay. So one thing if I am saying number of division, in which scale number of division is more? One division is more temperature, in which we can say in the 3 scale one division is the more bigger value, we can say in which scale all are equal. Why? If you see the values, so scale X has how many division? 90. Scale Y has how many division? 90. Scale Z has how many division? 90. Okay, so means each division in the all the scales are, we can say, equal. Okay, now actual problem is what? Suppose this scale is showing 50 degree X, its reading is 50 degree Y, and its reading is 50 degree Z. Scale thermometer X is showing 50 degree X, thermometer Y is showing 50 degree Y, and thermometer Z is showing 50 degree Z. Now I am asking, what is the order of temperature shown by the, what is the order of the temperature of the thermometer X, Y, and Z? Reading are same. X thermometer is showing 50 degree, Y thermometer is showing 50 degree, and Z thermometer is showing 50 degree. But reading same, then the temperature will not necessarily, temperature will be same. Okay, so I am saying what is the order of the temperature? What is the order of the temperature of the thermometer X, Y, and Z? If the readings are this 50 degree X, 50 degree Y, 50 degree Z, so what is the order of temperature? Means which thermometer is measuring the greatest temperature, and which thermometer is measuring the lowest temperature? Question everybody understood or not? Tell fast. Question everybody understood or not? Okay. Now there is a two way we can do this question. To compare the temperature, suppose I am saying I have the temperature 100 degree C, 50 degree C, 20 degree C. Suppose I am saying I have that we have the three temperature 100 degree C, 50 degree C, 20 degree C. Okay, if I am asking which temperature is maximum, then everybody will say, sir, 100 degree C. Which temperature is minimum? Everybody will say 20 degree C. So if all the temperature are in the same scale, then directly I can compare which temperature is more, which temperature is less. But when the temperature are at different scale, I cannot say that which is the maximum, which is the minimum. Directly I cannot say. Everybody got or not? So how I can do this question? One option is what? I will convert all the temperature in single scale. I will convert all the temperature in single scale. When it will get converted into the single scale, then directly I can compare which magnitude is more. Everybody got what we have to do? So all this temperature we will convert in one scale. Now, in which scale you will convert? Tell fast. In which scale you will convert? All these three temperature, I am saying what? We will convert in the one scale. So in which scale you will convert? Tell fast. Celsius. Maybe Celsius you are saying because maybe Celsius is easy to find, na? Okay. Nalayak. Why unnecessary? We have to introduce the one more. If you are converting in Celsius, who is saying the answer Celsius? If we are converting in Celsius, then all the three we have to convert in Celsius. Okay. So our work will be more. It will take more time. Why unnecessary? We have to introduce the fourth scale. We will, among these three, we will take any one. Suppose we are converting all in the terms of Y. Okay, anyone you can decide. All I am converting in the terms of Y. Okay, in the scale Y. So what will happen? Why you have to not convert in the Y? Because Y is already in the Y. So why necessary? We have to introduce the Celsius here. Okay, we will convert all the scale in a single. Okay. So anyone you can take, either you can convert all temperature in the X or you can convert all temperature in Y. Suppose I am saying all I am converting in Y, then only two I have to convert in Y, X and Z. Y is already in the Y, na? So we will not introduce the fourth scale because it will unnecessarily increase our work. Okay, it will take time. So what I'm saying, I'm converting all temperature in Y. Okay, so first I'm converting 50 degree X in Y. Okay, so I will write the TSI 50 minus what is the LFP of X, that is a minus 30 upon total number of division is what, 90, is equal to, I want to convert in Y, then I will write what, Y minus LFP of Y is what, 30, and total number of division is what, 90. Now 90 cancel out. 50 minus of minus 30 means it will be 80. 80 is equal to what, Y minus 30. Then Y what you got, 110. It means what I can say, 50 degree X is equal to 110 degree Y. So I got the 50 degree X in the Y. How much? 110. Then Y is already, we know that is a 50 degree Y. Okay, no need to convert that. Okay, it is already Y. Third, I will go to the Z. Okay, for the Z, again convert the Z into the Y. How? Z TSI 50 minus LFP of Z 0 upon 90. That is equal to what? In Y I want to find, so Y minus LFP of Y is what? 30 upon total number of division is 90. 90 cancel out. What is the Y value you got? 80. Then I can say 50 degree W is equal to 80 degree Y. Now all the three temperature you have in Y, 110, 50 and 80. Then what is the order of the temperature? Maximum is for X, then W, then Y. So what is the order of temperature? X, W and Y. Everybody got or not? Completed? Okay, so when all temperature are in the same scale, then it is easy for us to compare. Okay, sorry, W I am writing. Okay, 50 degree Z. Somebody was saying the W, that's why maybe. Okay, completed? Okay, now another way without calculating that, this method, why I said, because this everybody has to know. Okay, this will be applicable whenever the two reference temperature we are using. In this case, directly how we can decide because I am not asking the what is a 50 degree X, what is a 50 degree Z. Okay, I am only asking the order of the temperature. So easy way how we can do. Listen, 50 degree X, what is the UFP of the scale X? 60 degree. And what is the reading of this scale? 50 degree. So 50 degree X will be closer to the ice point or closer to the boiling point. 50 degree X will be closer to the ice point or closer to the boiling point. 50 degree X will be closer to the ice point or the boiling point. Boiling point, why 60 and then 50 means it will be somewhere here, suppose 50 degree X. Okay, then 50 degree Y. 50 degree Y will be closer to the ice point or boiling point. 50 degree Y will be closer to the ice point or boiling point. Ice point, why 30? Then 50 will be somewhere here. Okay, and 50 degree Z. 50 degree Z will be somewhere above the mid. Why? 0, 90. Mid is the what? 45. Okay. But I need 50, so it will be slightly above the mid. So means here 50 degree Z. Okay. Now you can say which temperature is closer to the BP? That is our X temperature. Okay. Which temperature is closer to the ice point? Y. And which is in between above that? Then it is a what? Z. Then which is at high temperature? X is at high temperature. Which is at the lower temperature? Y is at the lower temperature. What is the order of the temperature? X, Z and Y. Everybody got or not? So without converting in the TSI, we can go to this way fast. Everybody got? Okay. So a small question, which scale cannot give the negative reading? Tell fast. Which scale cannot give the negative reading? This is a very common small question, and in the chemistry also maybe you learned, and we learned the law, thermodynamics law also. Which scale cannot give the negative reading? Kelvin. Everybody know, I think. Fahrenheit. The Fahrenheit just now I shown for -40. Kelvin, because in the thermodynamics, in the chemistry, you will learn it is impossible to achieve the 0 Kelvin. That's why any engine efficiency cannot be 100 and the COP cannot be infinity. Okay, so 0 Kelvin is impossible to achieve. So negative Kelvin temperature we will not get. So if suppose this is small question they are asking, which scale will not show the negative temperature? So that is what? Kelvin. Okay. So now we have to discuss the graph. Graph already in the last class in the basic mathematics I discussed how to plot the straight line graph. Okay. So suppose I need the graph between Celsius and Kelvin. So one thing, we will not mug up any graph. Reason is what? When we are mugging any graph, on the x-axis what they are giving, on the y-axis what they are giving, then if we are mugging, then we will get confused. So we have to write the relation, whatever the relation we have in among the quantity, between the quantity, and according to that we will plot the graph. Okay, so we will not mug up. We have to know the process. So suppose here I am giving Celsius and here I am giving Kelvin. What is the graph between the Celsius and Kelvin scale? Graph between Celsius and Kelvin scale. So what we will do, first we will write the relation between Celsius and Kelvin. So K is equal to what? C plus 273.15. This is the relation. What I said, which quantity we are plotting on y-axis, that we will replace with y. Which quantity we are plotting on x-axis, that we will replace with x. So I am plotting the C on x-axis, K on y-axis. So K I will replace with y. C I will replace with x. So y is equal to x plus 273.15. So this is the relation I am getting. Y is equal to x plus 273.15. So everybody got this. Y is equal to mx plus c form. It is a straight line. Okay. How to draw the straight line? Maybe directly we can say also. I know directly y-intercept will be this. But I said the method is what? We will find one point on the x-axis, one point on the y-axis. For x-intercept, y will be 0. If you are putting y 0, so x value will come minus 273.15. Are everybody getting or not? Last class I said x-intercept y 0, y-intercept x 0. X-axis, on the x-axis y is equal to 0, on the y-axis x is equal to 0. So for the x-intercept I will put y 0. Y 0, so x I got minus, suppose minus 273.15 comma 0. This is the 1 point I got. Okay, then second point, for y-intercept I will put x is equal to 0. If I am putting x 0, then y value will come 273.15. Suppose somewhere here 0 comma 273.15. I got these 2 points on the line. Now join them, you will get the straight line graph. So this is the graph. Everybody got or not? Suppose I am saying this is a theta. What is a tan theta? Tell fast. What is a tan theta? What is a tan theta? What is a tan theta? Tell fast. 1. Why? Because slope of this line y is equal to mx plus c. What is the m here? M is equal to 1. And this theta is made by from the x-axis in the anti-clockwise. Then we can say slope is equal to what? 1. And even theta also you can say it is a 45. Okay. Completed. Okay. So second graph you will draw. F and C graph. So we have to plot the F and C graph, then we will write the F and C relation. Directly remember, it is okay, otherwise we will equate the TSI. So F, what we can write? F is equal to 9C by 5 plus 32. Now, F I am plotting on y-axis. So F I am plotting on y-axis. So y is equal to C I am plotting on x-axis. So that will be what? 9x by 5 plus 32. Then what we got? Y is equal to mx plus y is equal to mx plus c. Okay. Now again you will do the same for x intercept. X intercept y is equal to 0. If you are putting y 0, then x value what you will get? So x intercept y is equal to 0. Then x value what we got? Minus 160 by 9. Cross multiplying you will get the minus 160 by 9. So 1 point you got on the x-axis what? Minus 160 by 9 comma 0. Then for y-intercept we will put x0. X when you are putting 0, so then what you got? 32. It means another point what you got? 0 comma 32. Now join them, you will get the straight line graph. Okay. If suppose I am saying this is the theta, so what is the tan theta? Tell fast. What is the tan theta? What is the tan theta? 9 by 5, because y is equal to mx plus c. So in the place of m, what we have? 9 by 5. So we can say tan theta is equal to 9 by 5. Okay. So what I said, no need to mug up the graph, because here we are drawing the graph like this and slope we are getting 9 by 5. But suppose they interchange the axis. They have taken the c on the y-axis and f on the x-axis. Then what will happen? X-intercept, y-intercept will change, slope will change. So we cannot directly mug up. We have to know that how to plot the graph. Completed? Fast? Okay. Okay, so one question fast you will say. So I gave the graph between the any scale A and the Celsius scale. Okay. This is the straight line graph I gave. If I am saying if scale A reads 60 degree A, then find reading of Celsius scale. Tell fast. This is the graph I have not given directly LFP, UFP. What I gave the graph, and for the thermometer A, I gave the A and the Celsius, I gave this graph. Now I am saying if the thermometer A shows the reading what? 60 degree A, then what is the reading of the Celsius thermometer? So what we can say here, 0, this is the 0 degree C. 0 degree C is the LFP of Celsius. Then what is the LFP of A? 20. 100 degree C is the UFP of Celsius. What is the UFP of A? 80. Okay. By this graph, I can say UFP of Celsius, we know that 100. Then what is the UFP of the A? 80. LFP of Celsius is 0. What is the LFP of the A? 20. Now I can use the TSI relation directly. Now A, what the A read? 60 minus LFP of A, 20 upon UFP is what? 80 minus 20. That is a TSI for A is equal to, I need in Celsius, then C minus 0 by 100. Are everybody getting or not? So 60 minus 20 is what? 40. 80 minus 20 is what? 60. That is equal to C by 100. Okay, now 0, 0 cancel out. Then we can say what? This is the 2 by 3. Then what is the C value we got? 200 by 3. 66.6. Everybody got or not? So by the graph also we can get the question like this. Okay. Okay, so take the 5-minute break, then the puncher will start. Okay. So you can solve the question based on the thermometer scale. Triple point thermometer I will discuss in the next class. Okay. Any doubt up to this? Any doubt up to this? Okay. Okay then. Good. Okay. Okay then. Bye bye. Any doubt you will have, then next class you can ask. No problem. Okay.